Today we're going to learn how to identify and predict products for combustion reactions. So combustion reactions happen when an element or a compound reacts with oxygen, often producing energy in the form of heat or light. So when you hear combustion, you should think like fire or some sort of burning. And then in order for fire to burn, you have to have oxygen. So how you're going to identify combustion reactions is one of the reactants is going to be oxygen or O2. In this class, we're going to specifically look at the combustion of hydrocarbons. So hydrocarbons are just molecules that consist of hydrogen, which is hydro, and carbon atoms for carbons. Okay, so you're looking for molecules just made up of hydrogen and carbon. And so when we burn them, we're just going to react them with oxygen. And then this time you get the same two products every single time. So the two products you get are carbon dioxide and water. So how you're going to recognize this type of reaction is you're going to start with a hydrocarbon. Okay. So some sort of molecule made up of carbon and hydrogens. And then your second reactant is always going to be oxygen. And then for combustion reactions, you just have to memorize the products. The products are always carbon dioxide and water. All right, so now we're going to do just two practice problems together. So first we're going to combust C6H6. Okay. So if we're combusting them, we're going to react them with oxygen, which is O2. And then we get the same products every single time. So we're going to get CO2 and H2O. So now we're going to go through and balance. I'd recommend starting with carbon. So there's 6 carbons on the left side. So I'm going to add a 6 on the right side. Next, I'm going to move on to hydrogen. So there's 6 hydrogens on the left. So I'm going to add a 3 in front of hydrogen. So now I have 3 times 2 and 6. And now I'm going to add up all of the oxygens on the right side. So the 3 distributes. So there's 3 here, plus 6 times 2, which is 12. So 12 plus 3 is 15. So I need 15 oxygens on the left side. And remember, I'm going to do that trick I taught you last week. I'm just going to pencil in 7.5. Okay. So technically right now I have the correct ratios. However, we can't have a coefficient of 7.5. So now I'm just going to go through and I'm going to double every coefficient. So I'm going to have 2, 15, 12, and 6. And I'm just going to rewrite it so we can read it well. So I have 2 C6H6 plus 15 O2 gives us 12 CO2 plus 6 H2O. And then finally, we're just going to go through and make sure everything is balanced. So 2 times 6 is 12, and then 12 carbons. 2 times 6 is 12, 6 times 2 is 12, 15 times 2 is 30, and then over here I have 12 times 2 is 24, plus 6 is 30. Okay, now we're going to do example 2. This time we have CH3OH. So even though there's an oxygen in here, it's still made up of carbon and hydrogens. So it'll follow the hydrocarbon plan. So if we're going to combust it, we're going to react it with oxygen. And then we're still going to get the same products. So we're still going to get carbon dioxide and water. And so then now all we'll have to do is balance. So there's 1 carbon, 1 carbon. 3 plus 1 is 4 hydrogens. So I'm going to put a 2 over here. So 2 times 2 is 4 hydrogens. And then for oxygens, we have 2, and 2 is 4. Over here we have 2 and 1. So on this side I have an odd number and an even number over here. So I'm going to try placing a 2 in front of CH3OH to get it to an even number. So now I have 2 carbons. So I'm going to put a 2 on this side. And then I have 2 times 3 is 6. And then 7. Nope. 2 times 3 is 6. And the 2 distributes, so 8. So I'm going to write a 4 over here. So now I have 4 times 2, which is 8. And then for oxygens, I have 2 times 2, which is 4, plus 4 more is 8 total. I have 2 right here, so then this needs to add up to 6. So I'm going to put a 3 in front of it.